Hey guys, so today we're going to review some solving equations just like we did last time, one-step, two-step, multi-step equations, with a couple interesting cases that we'll discuss too. So number one is 12 minus 3x equals negative 6x. Notice there's no like terms on the left side by itself, no like terms on the right side by itself, so we want to focus on getting x alone on one side. So let's start by moving this 3x over to the right side. We want to bring down anything that wasn't affected, so 12. This becomes 0, it cancels, equals negative 6x plus 3x is negative 3x. Now if you want to highlight the variable you want to get alone, which is x in this case, we want to get rid of this negative 3. Well, negative 3x, this is multiplication right here, so the opposite operation in order to get rid of the negative 3 would be dividing by negative 3. So now the negative 3 cancels on the right side, and we're left with negative 4 is equal to x. In math, we usually write the variable on the left, so x equals negative 4. Okay. Number two. Number two, again, no like terms separately on both sides, but eventually we're going to have to combine things after we distribute this piece right here. So make sure you don't move around anything in the parentheses until you distribute. That they're trapped right now. So when I distribute this 4, I like to circle it because sometimes when it's negative, people will forget. And draw your arrows. 4 times 1 is 4. 4 times negative p is negative 4p equals negative 4p plus 4. Now, notice these two sides are the same, positive 4, positive 4. Negative 4p, negative 4p. They're just flipped, but they're the same exact terms on both sides. Now, you don't have to continue this problem, but I'm going to show you what would happen if you did. So if I added 4p to both sides, both of those would cancel, and I'm left with 4 equals 4. You can continue that and end up with 0 equals 0. The reason I'm going to stop here is because the variable has disappeared, and that will always happen if they're the same exact terms on both sides. What this means, and you can even identify it from this step over here, is that both sides of the equation are equal. It's a true statement. If I ask myself, does 4 equal 4? And if the answer is yes, and it would always be the case no matter what you plug in for p, that both sides are going to be the same, then you just write all real numbers. It's a special case. That means that I can plug in any real number, and this will always be true, this equation. There's not just one number p equals. Okay, let's go to one with fractions. So I'm just going to help you guys remember that we can clear fractions. In this case, actually, if you distributed the 5/6 and to the 6m and to the 10, the fraction would clear automatically. But if you just don't want to deal with it from the start, then you can get rid of it by multiplying by the least common multiple of the denominators you see. There's only one in this case. So first things first, combine these like terms. Now notice the least common denominator, there's only one, so it's just going to be 6. And to clear it, we multiply both sides of the equation and every term by 6. So times 6 here. Since it's a fraction, I'm going to write it as 6 over 1. Notice I am not going to multiply anything in the parentheses by 6 over 1. Anytime two terms are attached by multiplication, they count as one big term. So this 6 right here, if I just multiply it by 5 over 6, it's automatically happening to these two as well. So I don't need to multiply the pieces inside. Okay, so now over here we get 30m equals, the 6's cancel, 5 times 6m minus 10. Distribute the 5. 30m equals 30m minus 10. Okay, interesting. I have a 30m on both sides. Let's see what happens when we try to get it to one side. Minus 30m minus 30m. I'm going to write over this. 0 equals negative 10. Now, again, anytime you get rid of the variable, ask yourself, is it true? If it's true, your answer will be all real numbers. If it's a false statement, that means this right here, this wasn't even an equation to begin with. These two were not equal. 0 does not equal 10, and I can put a cross through it. The final answer to this would just be no solution. True statement would be all real numbers. A false statement would be no solution. Okay. Let's do one more. Here's another one where I can clear fractions. Now, again, I'll tell you this, that this problem was created so that when you multiply or distribute the fractions in front, the fraction's going to automatically disappear. If I want to avoid fractions completely and not have to think about that, I look at the common denominators. What's the least common multiple of 2 and 3? The least common multiple of 2 and 3 is 6. So I'm going to multiply both sides by 6. Notice the terms next to it. I will not multiply these by 6, nor will I multiply these by 6, because they're connected through multiplication of the parentheses. If they were separated, then yes, I would multiply every single term by 6. So here, cross cancel. 6 divided by 2 ends up being 3. 6 divided by 3 ends up being 2. And now I have a whole number to distribute on both sides. I'm left with 30 plus 36n is equal to 30n plus 30. Simplify, combine your like terms if you have any. Right now we have a 30 plus 36n on one side and a 30n plus 30 on the other side. This is going to be a common mistake you guys make, so just watch carefully. I'm going to subtract the 30 from both sides. That's an easy one to get rid of. I have 36n equals 30n. Some students will go straight to dividing by the 30 or the 36 to get n alone. You cannot get n alone until you combine these n's. Remember, they have to be alone on one side. So I'm going to try to combine them by subtracting 30n from both sides. Here I'm going to get 6n, and on the right I'm going to get 0. This doesn't mean no solution. Continue the problem. Here, to get n alone, I divide by 6. A 0 divided by any number is just 0. So there's your final answer. Okay, so that's it for reviewing. We're going to move on to the next topic.